Okay, we're going to solve this equation for all real solutions in simplest form, and we're going to use the quadratic formula. So for this problem, it says 2y squared minus 19y plus 17 equals negative 3y squared. What I'm going to do is I'm going to change these to x's, so that's a little bit easier for me to read this. But we got 2x squared minus 19x plus 17 equals negative 3y, or negative 3x squared. What I need to do is set this to 0, so we're going to add 3x squared to both sides. So this is going to change this. This is going to go to 0. We're going to add 3x squared to these two terms. So this is going to go to 5x squared. And now I'm going to plug this into the quadratic formula. This is your A. I'm going to turn this to blue here. So this is your A. Here's your B. Here's your C. So the quadratic formula says that given standard form, we have x equals the opposite of b. So we're going to put 19 plus or minus. We're going to square b minus 4 times a, which is 5, times c, which is 17. That's an ugly looking root. Very ugly looking root. And then we're going to divide that by 2 times my a, which is 2 times 5. So we're going to go ahead and evaluate certain parts of this. 2 times 5, that goes to 10. We're going to take the 19 squared minus the 14 times the 5. We're going to calculate that first. So let's go into our calculator. 19 squared minus 4 times 5 times 17. That's going to give us 21. So we're going to take all of this inside here, and it changes to 21. And then we need to reduce this if we can. If we look for factors of 21, the only ones that we're going to really find are 1 and 21 and 3 and 7. Both of those are prime. So this actually stays underneath the root like this. So this is the final answer for this one. We're just going to take 19 plus or minus. So the first thing I'm going to do is create my fraction bar. 19, hit the plus or minus, square root 21. Put it over 10. I would reduce it where I need to, but 19 is prime, so only one is prime, or not prime, it's a composite of two primes. And there you go. Where's our factor of two primes? There we go. Okay, we'll do one more. Let's see what we get. Okay, so we'll clear these out. And we'll try another one. Okay, so we have 6n squared plus 7n minus 11 equals 5n squared. Okay, first thing I'm going to do is I need to take this 5n squared, make it go to 0, which means I'm to subtract 5n squared from 6n squared, which means we're left with just n squared. So now we have our a, which is 1, our b, which is 7, and our c, which is negative 11. So quadratic formula again, we're going to go x equals the opposite of b, which is negative 7, say plus or minus. We're going to put 7 squared minus 4 times 1 times negative 11. That's all going to be underneath the root. Divide that by 2 times our a, which is 2 times 1. We're just going to leave it as 2. So let's go ahead and evaluate 7 squared minus 4 times negative 11. So 7 squared minus 4 times negative 11. We don't worry about the 1 now. And we get 93. So we're going to get this part changes to 93. We're going to look for factors in 93 to make sure. I do not think it has any factors that we can use. So we'll just make a quick table, turn this to x, but this is 93 divided by x. We'll go 1, 2, 3 and 31. And that looks like it's it. It was just two sets of factors that we have, 1 and 93 and 3 and 31. 3 and 31 are both prime numbers, so this is as simple as it will actually get in this. So create a fraction bar, negative 7 plus or minus the square root of 93 over 2.